So this is the question of another board, so useful to people of A level. So this is a concern with the chapter current electricity, actually DC circuits actually. So it says that the diagram shows two batteries of EMF 6.0 volt and 4.0 volt. So here connected in a circuit. The inner resistance of each battery is negligible. No internal resistance here and here. So we have to find what is the current in the battery of EMF 4.0 volts. So we have to find what is the current through this battery. So for the purpose, what I can do is, since this is positive, let me say it gives a current I1, let's say, and since this is positive, let me say this also gives a current something like I2 here, and here this I1 and I2 combined, so let me say it becomes I3. So if this is I1, this should also be I1, because in order to have I1 here, we should have I1 here as well. So if this is I3, this will be I3, and if this is I2, this should be I2. So now if we consider this loop, only and apply Kirchhoff's law, Kirchhoff's second law actually, we will have the EMF in this loop, in this closed circuit, is 4.0, and the source of PD is this resistor. So I must have, from here I should have 4.0 should be equal to the PD here. So it is equal to I3 into 20. So it gives us I3 is equal to 4.0 by 20, and this becomes 0.20 ampere. So I3 is equal to 0.20 ampere. Now if I consider this loop here, this outer loop actually, if I consider this loop, then I will have the sum of EMF here will be equal to 6 minus 4, because 6 tries to apply force here and 4 tries to apply force here, so they oppose each other. So it will be 6.0 minus 4.0 should be equal to, the source of PD here is this resistor, so it should be equal to I2 into 40. Then as you come from here, there is no other resistor at all, so our equation will be just this much. So it is 2.0 is equal to I2 into 40. So that means I2 is equal to 2.0 by 40 is equal to 0.050 amperes. So we have this as 0.20 ampere and this as 0.050 ampere. So that means now at this loop I must have, when I apply the first law of Kirchhoff, it should be I1 plus I2 should be equal to I3. Now since I have to find the current through this cell, I need to find I1. So or I1 should be equal to I3 minus I2, that's equal to 0.20 minus 0.050, and that's equal to 0.15 ampere. So the correct choice of answer should be choice number 2, choice number B actually.